What's going on, everybody? My name is Terry. Today we are going to be looking at some Unity code, and specifically Unity code to do the very basic movement of a ship in a game. So what that entails is being able to turn our ship like this, rotate our ship like this, bring our ship up and down on a pitch like this, and move it forward and backward like this. So if that sounds interesting, go ahead, smash that subscribe button, hit that like button. It really does help us out, and we'll hop right into this. All right, so the first thing we're going to talk about is a little bit about how plane and ship rotation works in a 3D space. Now, this won't be quite the same as Unity, but an example of this is when we have a plane, we would like for it to be able to do barrel rolls. That's the roll. It would like for it to pitch. That's going up and down, like lifting the nose up and down. And then yaw, which is sort of like rotating the plane on a dime, so to speak. So we have to code all three of these elements into our code, and luckily for us, this is actually fairly simple. So the first thing we're going to do is open up a totally blank script. This is a totally blank script. It's called BlockFighter because the fighter that we are using is just a set of blocks. So, you know, I used my amazing naming scheme and called it BlockFighter. The first thing that we really need to do in this script, though, is to nail down some of the variables that we're going to be using. So primarily first, what we're going to need is a public transform of the ship. So we're going to grab essentially the model. So we need that transform, and we're going to call this ship. You can call it whatever you would like. Just designate that this is the ship that we are in fact working on. The second thing that we're going to need is the rigid body, and that is just to turn off gravity. So we'll just call this a rigid body, and we're just going to call this R, and we'll deal with that in a second. Then we're going to need to do some stuff with speed, and then we're going to need to do a section for future variables. So for right now, all we need to do on speed is to talk about our turn speed and our movement speed. So what we need is a public float called turn speed. And we're just going to assign this a value here. We can change it in the editor, but I find that 60 is a pretty solid turn speed. And then we're going to grab a boost speed. And a similar thing, we're just going to assign a thing here, even though we can edit it in the editor. It is worth noting that anything that you do in the editor, if I save this script here, anything that you do in the editor, so this is our cube right here where this is attached, anything that you do in the editor here will supersede what happens in the code. So if you change this to 70 here, it will go over the code. Not anything too crazy. So most of the things that we need to do in this function or this set of functions happen as movement of a character. So generally we want to throw that into fixed update. So I'm just going to call fixed update here. So if you don't know what fixed update is, it happens before the update is called. It's called every fixed frame rate. If you would like a video on the Unity lifecycle, our channel has a video on it, and I will put a link in the description below. But essentially, we wanted to control our movements in fixed update as opposed to update because we want it to happen on every physics frame, and it has to happen on every fixed interval. It's a little bit complicated, but we're just going to do it in fixed update because it's a little more accurate, especially when we're dealing with transforms moving. So in here, we're just going to call the two functions that we're going to create, and I will create those now. So the first thing that we're going to do is we're going to call our void turn. So turn is just going to control all of our pitch, yaw, and roll. And then we're going to have one that just controls thrust. So if we do void thrust, we can just have one that controls the thrust of our thing. And we're just going to call these inside our fixed update. This is a way to keep our code just a little bit cleaner and a little more segmented out. So inside our turn, we are going to get into some input.getAxes. And these are how we're going to control a lot of what we're doing today. But in order to do that, we need to go into our Unity and take a look at them. So I am in the project settings window. If you don't know where that is, you can go edit project settings and it pops up this window. It'll usually pop it out like this. You can click and drag it wherever you'd like or just manage it popped out. I generally prefer it to be over here as part of this, because it's a little bit simpler for me. So what we're going to do is we're going to come down here to the input manager where there are going to be axes right here. And right now there are 18 fixed ones within Unity. We're just going to add a couple more. So we're going to change the size of that array in Unity to 20. And what it'll do is it'll copy the last one and it'll just make a duplicate of the very last element of the array. So we're going to create a couple of axes here. Primarily, we're going to be concerned with rotate and throttle, because we're going to use throttle here and it's going to do some cool stuff for us. So earlier on, I talked about this roll, pitch, yaw, and we're not going to use quite the same terminology here just because we're going to end up using the vertical and horizontal axes that are already pre-programmed. So I'm just going to call this one rotate, and the rotate is going to be our roll. So when we rotate around the z-axis, this would be the plane doing a barrel roll, if you will. So what we want to do is set a positive and negative button for this. And we can use vertical or horizontal as an example here. You see how they have a negative button left to turn left on the horizontal axis and right to turn right. That's using a positive one or a negative one to control the character. We're going to do something similar here with rotate. So let's say that if we hit Q or if we hit E, we are going to roll. So if we hit Q, we want to roll to the left. If we hit E, we want to roll to the right. And then we're going to change this to match this up here. Gravity and sensitivity, these are how fast and how long they hold the input. So it sort of ramps up a little bit if you set sensitivity a little bit lower. It takes a little bit longer to ramp up to max speed of the roll, or if you set it really high, it'll quick snap. And then vice versa, the same is true for gravity. If you extend out gravity, it takes a longer time to slow down, and so on and so forth. The other thing that we want to do is enable snap. And we're just going to mirror the same thing down here before we put these things in, because these are just going to be the same. This one we're going to call throttle. So we're going to use this to control our forward and reverse thrusters. We have not added momentum into this. We will get to that in a later video. But for right now, we would really like to be able to control a forward and back throttle. And what we're going to do is we're going to assign this to left shift and right shift. Now, Unity is pretty particular about spelling here. It has to be lowercase only. If I put something that's a little bit off, so let's say that I put, left shift without a thing in all capitalized and I hit enter, it just deletes it. So it's pretty important that you use lowercase only, and for whatever reason that's what they like, so that's what we're going to use. Let me open that back up. So we have left shift and right shift. We're going to take away that joystick button. Same thing, gravity and sensitivity of 3, and we're just going to snap it. You don't have to worry about any of this stuff like key or mouse button, x-axis, get movement from all joysticks. Does not matter. Just leave those as is. We just need to set those up. So what we're going to do then is hit save. So it saves those things in our input manager so we don't have to go back and do them. Now in our code, we need to go ahead and use those objects. So what we're going to do is we're actually going to edit what the ship is doing. So we can do a this ship dot rotate, and if you see here, the auto fill in of Visual Studio 2019 is telling me that I can do all sorts of things, but primarily we're concerned about 406 here that allows us to give us an X angle, a Y angle, and a Z angle. So we're going to give that our pitch, our yaw, and our roll, like I said with our plane. So in order to give it that, we need to create those things. So let's go ahead and create a float yaw. And we're going to give this a few different parameters. Earlier on, we came up here and we said that we had a turn speed. So we're going to grab that turn speed. And we're just going to multiply this on time.delta time, just so, like, you know, it has a little bit of extra oomph on our movement. And then we're also going to attach that to our axis that we set up. So if we do our input.get axis, and then we are going to grab the horizontal axis. So this one is our yaw. So traditionally in our XYZ thing, how we talked about here, we have 3 numbers here. So let's go ahead and fill this in with 0, 0, 0. So this is a standard not moving ship. If we would like for it to move, we need to set our yaw to do something based on the inputs that we give it on the horizontal axis. And when we do that, like I said earlier, we want it to move around like it's rotating. So we're rotating along the y-axis, this up and down. I know this image has it labeled as Z, but in Unity, Y is the one that goes up and down. So we're going to rotate around the y-axis. So in our code, remember this goes X, Y, Z. That means we want to put our yaw in here. Now, if we want to do our pitch, we're going to do something a little bit similar. So we're going to set this equal to our turn speed because we are still using a turn. We're still maneuvering the ship around in space. And it would really help if I actually spelled things correctly. So let's go ahead and make that a float. And just as before, we're going to use the same time.delta time. And just as before, we're going to ultimately multiply it by an axis. So we're going to do an input.get axis. And this time, since we're doing pitch, that's forward, up, and down, and we want to use W and S, or up and down on the arrow keys, we're going to use the vertical axis. So let me assume that I spell this correctly. And we have our pitch. Now, again, if we judge this based on our image here, pitch is the one that controls whether the nose goes up and down. It rotates along this sort of side-to-side axis. So if we go into Unity, we can see how Unity does this here. So this will be the x-axis. So we need to go into our code and take this one, the 0 that's representing the x, and change this one to pitch. And finally, the last thing that we need to do is do that roll. So let's create a float roll. And we're going to set this equal to, again, our turn speed. And I will make the same mistake in coding again. So we're going to set it again to our turn speed because we're still rotating the ship here. And we are going to change this times delta time. And then finally, we're going to give it another input. So this input is going to also be an axis, and this one is going to be the one that we created before. So because we have used the standard axes up already, we need to do the one that we created. So in Unity, we created this one down here called rotate, and that uses Q and E to rotate. And we're going to assign that Q and E to rotate around this long axis here. This one that in this picture is labeled as X. But in Unity, if I rotate this camera just a little bit, you can see that this is actually the Z-axis. It's a little hard to see with the sky block there. But the Z-axis is the one that sort of goes along the nose of this ship. So we called this rotate before. So now we have roll attached to rotate. And since this is the Z-axis, we're just going to put it in here for where we have that Z for 0. So now we have our X changing based on our pitch, our Y changing based on our yaw, and our Z changing based on our roll. So these are things that you use in actual aviation, and we're going to do our best to emulate that in code. So now if I go ahead and hit save and go to Unity, if we hit play, I realize that I forgot to do something. Primarily, I did not assign this ship in our inspector. So here is our block fighter. We need to assign this ship here. And that reminds me of one really important thing that we forgot to do. So we're going to do something within start here. This is just a thing that you need to do in most space games. This would help if I don't have caps lock on. What we need to do is actually assign the rigid body and then turn off gravity. So we're going to do R, that rigid body that we created up here, is equal to get component. And we're just going to grab the rigid body to which this script is attached. And then we're just going to do r.useGravity and just set that equal to false. That's a Boolean, so we can turn that on or off. So if we set it to false, our model won't fall to the block here. So now when we hit play and we have things actually attached, you can see that when I hit left on our keypad, we start rotating around on a single point. That is our yaw. And if I hit Q, we start to rotate. E, we start to rotate the other way. And then W, we rotate up. S, we rotate up. And W, we rotate down, rather, sorry. So here we have the rotation of our ship. So Q and E do our barrel roll. W and S go up and down. That's our pitch. And then our yaw is A and D. And that is basic 3D movement and rotation. So now all that we have left to do is attach that throttle. So let's go ahead and save this here. And we'll hop right back into our code. And again, we have this thrust that we've already done. So this should actually be fairly simple, given that we've already set up the axis for it. So what we're going to actually do is grab this ship. So again, we're taking this transform, and we're going to set the position, and we're just going to change that by whatever we adjust it to as we play. So as we adjust the input axis by pressing left and right shift, we're going to adjust our throttle. So what we're going to do is we're going to grab the relative location of this ship. We're going to say we want to look at the forward of this ship. And I'll get back to this in a second. There's a chance that we have to change this based on Unity. It can get a little bit messy, but we'll get back to it in a second. And here, up here, we assigned boost speed. So that's our movement speed. And again, we want to multiply this by time.delta time. And then finally, we want to provide that input of the axis. So instead of rotating this time, we're just changing the position of this ship. So we need to do this input dot get axis. That's why this is a plus equals instead of just a equals. So since we're actively changing the position of the ship every time we hold down a left or right shift, that we need to do this as a plus equals. So we're going to grab a get axis, and then we have already set this up to be throttle. So all we need to do is just drop that semicolon in there. And now, when we come to our ship and we hit play, we can see that if we hit left or right shift, so there's a chance this actually goes the wrong direction. So left shift will go forward, right shift will go backwards. There's a chance that when you do this, yours is a little bit off. And all you need to do is just drop a negative here if it's going the wrong direction. So if forward is not, for whatever reason, pointing in the right direction because Unity is Unity, just go ahead and drop a little negative there, and then instead of going backwards, your ship will go forward. That's just a little caveat that I come across. It's easier for me to deal with it in code than it is for me to go up here and handle all the child rotations and all that stuff. So I typically just do it in code. But as of right now, if we press left shift, we go forward, right shift, we go backwards, and we can start to fly around, do barrel rolls, things like that. So if you have any questions on how this works or anything like that, go ahead, leave me a comment down below. I'm always more than happy to help. You can find a link in the description to our Discord. There's lots of people in there who know a ton about coding. Go ahead, drop in there. We'd love to hear from you. If you find this to be extremely helpful, go ahead and take a look in the description. There's several links from our Patreon to our Twitch. You can give any of those a follow or a click. That will help us out immensely. As always, I hope this has been helpful. Like, comment, subscribe, all that jazz. It really does help, and hopefully we'll see you next week.